Solving exponential and logarithmic equations. So these are the two topics we're going to discuss in this section. First of all, solving exponential equation. Let's say you have exponential equation like this, where the variable x is on the exponent, or here the variable x is on the exponent 2 to the power 5x. So this type of equation, they are called exponential equation because we are using exponential function here. How do we solve? The first thing is, if you have same base, or if you can convert your equation in a way that the both side can be expressed as the same base, then we can use base exponent property. Both side can be expressed as same base. Here in this case it's a to the power x equal a to the power y. It means the exponent has to be equal. So here 3 to the power x, so the base is 3 on the left side, 20. Can we express 20 as a 3 to the power something? So we know 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27. So we cannot express this as a 3 to the power something. So we cannot apply this base property here. But what about this one? 2 to the power 1, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64. So this one, it's a 2 to the power 5x equal 2 to the power 6. Because of this base property, 5x has to be equal to 6. So x has to be equal to 5 over 6, 6 over 5. So we can sometime use the base property to solve exponential equation. Sometime we cannot. In that case, if we don't have same base, then still we can solve problem by taking ln both side. So if you take ln here, or log function, you see this x, we can bring it down using the power rule. So the answer would be x equal ln 20 over ln 3. So that is the answer for the first one. So we can solve if you have same base using the base property. If we don't have the same base for the exponential equation, we can solve that type of equation by using the log function. Here I used ln, but you can also use LOZ. It's up to you. We can also solve logarithmic equation using log property. For example, if you have log function on one side and then log function on another side with the same base, then m has to be equal to n. So in this case, there is a log on one side, but there is no log on the other side. So we cannot apply this property here to solve the first equation. Can we solve the second one? You can express the first one as a log, one log function, which is x over x. Sorry, it's not over, it's a multiplication because there is a plus sign, which is x times x plus 3. And other side there is a 1, but you can also write down 1 as a log 10 because log 10 is 1. So now because you have a log and log both sides, you can apply this basic property to solve this log function. So one thing you have to keep in mind, whenever you try to solve log function, you have to be careful with the domain. What values of x are acceptable? So these are the things we have to be careful here while solving the log equation. So let's look at some examples. Question number 1. Solve this equation. Can we express both sides of the equation as a 2 to the power same base? So the answer is yes. Or can you write down to 256 as a 4 to the power? So 256 factor 2 1, 2, 8, 2, 64, 2, 32, 2, 16, 2, 8, 2, 4, and then 2, 2. So how many 4s are there? 1, 2, 3, 4. So 256 is actually 4 to the power 4. Okay. So on the one side there is a 4 to the power 8x minus 7. And on the right side there is a 4 to the power 4 by using this 2, this 2, this 2, and finally 1, 4. So because of the base property, we can write down 8x minus 7 equal 4 because the exponent has to be equal. Now we can add 7 both sides. That gives us 8x equal 11. And then if you divide both sides by 8, x equal 11 by 8. That's the solution. So what is the x? X is 11 over 8. You can always check your answer by plugging x equal to 11 over 8 here in the given equation. What about this one? Can we express both sides of the equation as a 3 to the power something? The one side is 3 to the power x, and then another side is 7, which we cannot express as a 3. So for problem like this, we can take LOG log or ln both sides. By doing that, we can use the power rule of the log function. We can bring this x down here. So log 7 is a number, log 3 is another number. So for finding the x, just divide both sides by log 3. And then answer would be x equal log 7 over log 3. Okay, round to the 4 decimal places. So they are asking us to use a calculator for rounding. Calculator. Log 7, where is the log? Log 7. Log 7 divide by log 3. So type 3 first and then log 3. Parenthesis close. So that is 1.7712. If you round it to the 4 decimal place, 1.7712. 1.7712. You can take ln both sides, and ln of e is 1, so t equal ln 912. Type an integer or decimal, so this is ln 912. So 912 ln. That's the answer, which is do not round until the final answer, then round to the 3 decimal place. So it's 6.816. 6.816. Okay, here log base 2x equal 1. This can be done by changing the log equation into the exponential equation. Log base 2x equal 1. What is the x? We can always write down log base 2 of 2. This is 1. We know that for sure. So log base 2 of x equal 1. So what is the x? So this is actually x equal this base to the power 1, which is 2. And that is acceptable because inside the parentheses the positive number is fine. The solution is 2. So here log x equal -2, that is not x equal -2. So x equal 10 to the power -2, which is 1 over 100. Which is 1 over 100. Because 10 to the power -2 is 1 over 100. Okay, this one. Because both sides it has log base 3, so we can use that property of log function. First of all, we need to use the product rule to combine the first one, so quotient rule to combine the first two log function on the left side. Log base 3, because there is a minus sign, it can be written as t plus 32 on the top and then t plus 5 on the bottom, and on the right side there is a log base 3 of t. Because they have the log with the same base, this supposed to be equal to this, which is t plus 32 over t plus 5 has to be equal to t. So you just multiply both sides by t plus 5. It would be t plus 32 equal t square plus 5t, and then bring everything to the other side. That will be 0 equal t square plus 4t minus 32. If we subtract t and then 32 from both sides, so this is the equation we're going to get. So this is actually t plus 8 times t minus 4, because plus 8 times negative 4 is negative 32, plus 8 minus 4 is plus 4. So the answer for this expression is negative 8 and positive 4. These are the two options. But after finding the answer, you always have to check here. What happens if I put negative 8 here? This is positive. If I put negative 8 here, that will give me the negative, which is not acceptable for the log function. So I cannot pick negative 8 as one answer. What about the 4? 4 plus 32 is positive, 4 plus 5 is positive, 4 is positive. So the only answer I can pick is 4. Make sense? After finding your solution, you always have to go here and then check back. Okay, that's all for this section.